What we're going to do today is write a repeating decimal as a fraction. So let's take, for example, this is an ellipsis. That means that this pattern continues on forever. This can also be written like this. This bar, again, lets you know that that pattern, that digit, repeats forever, okay? So right now, we're just gonna focus on one digit repeating. I'm gonna create an equation, and I'm gonna say x is equal to my repeating decimal. Now, my objective is to represent this repeating decimal as a fraction, and it's also to eliminate the repeating digits, okay? So stay with me here. So because this repeating decimal is in the tenths place, I am going to multiply both sides of this equation by 10. 10 is the reciprocal of tenths. The reason why I'm doing that is because, again, I want to eliminate the repeating digits, okay? So in order for me to do that, I'm going to have to create a whole number. So 1x times 10 is going to give me 10 x's. And then this 3 tenths repeating is going to give me, and the 3 is still repeating. The only difference is now I have a whole number, right? And these equations are equivalent. They have the same exact solution because I did the same thing to both sides. So now that I have this equation, it's going to allow me to eliminate my repeating digits. How, you may ask? By subtracting the repeating digits. So I'm going to subtract x from my x term, and I'm going to subtract what x equals from the constant. So notice here, this digit in the tenths place, when I subtract them, I'm going to have 0. And that's exactly what I want. 10x minus 1x leaves me with 9x's. And then 3 minus 0 is 3. So I have 9 x's or 9 groups of x's, but I only want one group of x. So how do I go from 9 groups to just one group? I'm going to divide by 9. So that leaves me with 1x is equal to 3/9. And I can simplify this because I know the greatest common factor between 3 and 9 is 3. So I can divide both my numerator and denominator by 3 to get 1/3.